Good day, class. Welcome to another edition of Scholars Universal Secondary School online chemistry class. I'm Solomon, an online chemistry teacher. In our last lecture, we introduced nitrogen, and here is the assignment of the last lecture, and here are the solutions to the assignments. In our lecture today, we're going to be discussing ammonia. Now, under ammonia, we're going to discuss its occurrence in nature, laboratory preparation, industrial preparation, its physical and chemical properties, and some important uses of ammonia, and how you can test for ammonia in the laboratory. Then after that, we're going to discuss some important compound of ammonia, which is the ammonium compound. Now, ammonia is a hydride of nitrogen. It is produced when nitrogenous matter decay in the absence of air. That means when nitrogenous matter decaying in the absence of air, ammonia gas is produced. For example, when plant decay or when animal decay, or any compound or any matter, organic matter that contains nitrogen, when it undergo chemical biological decay, its ammonia gas is formed. Now the decomposition is brought about by the heat or putrefying bacteria. Now due to its high solubility in water, it's easily dissolved in water and find its way into the soil, and then it is converted to other nitrogen compounds. Now to the laboratory preparation of ammonia. Now ammonia is prepared in the lab by the action of heat on the mixture of any ammonium salt with a non-volatile base. Now the most commonly used base we use in the lab for the preparation of ammonia is the calcium hydroxide, which is also known as the slaked lime. Now this is the equation of the reaction. This is the calcium hydroxide reacting with a ammonium compound, which is sodium chloride, forming the calcium chloride and also liberating ammonia gas. Also take note that some water molecule is also present, is also produced. Now the usual drying agents like the concentrated tetrasulfate, 6 acid and the fused calcium chloride are not suitable for drying ammonia because they react with the gas to form some complex compound. Now this ammonia, if it is dried with concentrated tetrasulfate 6 acid, ammonium tetrasulfate 6 salt will be produced. And if ammonia is dried using calcium chloride, a complex compound of calcium chloride dot 4NH3 will be produced. A complex compound of calcium chloride and ammonia will be produced. Now the drying agent we use in the preparation of ammonia is the calcium oxide, which is also known as the quick lime. Now this is a diagram showing the laboratory preparation of ammonia. Now this is calcium hydroxide reacting with the ammonium chloride, and it is being applied, and you can see the ammonia gas produced is passed through this gas and it is dried using this, and it is collected at this region. It is dried using the calcium oxide, which is also the quicklime. To the industrial preparation of ammonia. Now ammonia is prepared industrially by the direct reaction of nitrogen and hydrogen through the Haber process. Now please take note that this reaction is an equilibrium reaction, and we all know that for equilibrium reaction we have some condition for optimum production of the product we desire. Now for the optimum production of ammonia, the following conditions are necessary for the production of ammonia. Number one, the ammonia is prepared from Haber process at high temperature, at high pressure, at 200 between 200 to 500 atm, which is between 200 to 500 atmosphere, and at low temperature, which is 450 degree Celsius. And also the mixture of nitrogen and hydrogen must be in the ratio 1:3 by volume. Now if you look at the equation, the nitrogen gas and the hydrogen gas are in the ratio 1:3. And please take note that they are in the ratio 1:3 by volume. Now also to For the optimum production of the ammonia gas, we also make use of the catalyst, which is the finely divided ion. Now, under this condition, which is under this condition, for the optimum production of ammonia, we only produce 15% of ammonia. We're able to produce 15% under this condition. Now, the ammonia is then liquefied by cooling, and the unused gas are reused over the catalyst for further production of ammonia. Now, this is the diagram of the Haber process. Now, you can see the hydrogen gas and the nitrogen gas are passed into this region and into this region containing the ion catalyst. And after they are made to react, the mixture, the ammonia gas produced is passed into this region. Then spray of water is added to the gas to produce the ammonia solution. To the physical property of ammonia. Ammonia is a colorless gas with a choking smell, and it is poisonous in large quantities. Now, it is an alkaline gas because it turns damp red litmus paper to blue. It is about 1.7 times less dense than air. That's a boiling point of minus 34 degrees Celsius and a melting point of minus 77.7 degrees Celsius. It is very soluble in water, and this is the reason why it is used to describe the Fontaine experiment. Now, in our discussion about hydrogen chloride gas, we also mentioned that hydrogen chloride gas is also used to describe the Fontaine experiment because of its high solubility in water. Now, this is a diagram showing the Fontaine experiment of ammonia. Now, this is a solution of red litmus, sorry, and a jet tube is directly attached into the red litmus solution. Now, this conical flask contains ammonia gas. Water molecule is added to this region of the ammonia gas using this dropper. Then the red litmus solution is forced through this jet tube. Then a fountain-like structure is formed. Now, this is due to the reduced in air pressure caused by the ammonia gas on this red litmus solution. Please, let's take note of that. That's why we have a fountain-like structure when the red litmus solution is made to come into this region of the ammonia gas. And so the chemical properties of ammonia. Now, the first chemical property of ammonia we're going to discuss is its reaction with oxygen. Ammonia burns readily in oxygen with a greenish yellow flame to form water and also to liberate nitrogen gas. Now, this is ammonia gas reacting with oxygen to form water molecules and also liberating nitrogen gas. Now, to the next chemical property, reaction with carbon 4 oxide. Ammonia reacts with carbon 4 oxide at a high pressure of 150 atmosphere to produce urea, which is an important organic compound. And this is the equation of the reaction. This is ammonia gas reacting with carbon 4 oxide, which is carbon dioxide, to form urea. This is urea, and also forming some water molecule. Now, ammonia as a base. Ammonia is a weak base because it can accept proton from acid to form the ammonium ion. Now, this is ammonia gas, and this is a proton from acid, and this is the ammonium ion. Now, ammonia gas reacts with acid to produce the ammonium salt. Now, for example, the ammonia gas reacts with hydrogen chloride gas to form the ammonium chloride, which is a salt of ammonia. Let's take note of that. Now, action of it on ammonia. Ammonia is decomposed into nitrogen and hydrogen at temperature greater than 500 degrees Celsius or by prolonged sparkling. Now, if you can remember in the laboratory in the industrial preparation of ammonia using the Haber process. I made mention that for optimum production of ammonia, the temperature is at 450 degrees Celsius. Now you can see that at a temperature at 500 degrees Celsius, at a temperature of 500 degrees Celsius, the ammonia gas which is produced from that Haber process, from the Haber process, can decompose to form the hydrogen gas and the nitrogen gas. Now reaction with chlorine. Ammonia reduces chlorine gas to form the hydrogen chloride gas, and the ammonia gas is oxidized to nitrogen gas. That means ammonia behave as a reducing agent when it reacts with chlorine gas to form the hydrogen chloride gas, and it is oxidized to form the nitrogen gas. Now this is the ammonia gas reacting with the chlorine gas to form the nitrogen gas. That means the ammonia gas is being oxidized by the chlorine gas to form nitrogen gas, and the chlorine gas is reduced by ammonia to form the hydrogen chloride gas. Now if the ammonia is in excess, the hydrogen gas produced from this reaction will react with the ammonia gas, with the excess ammonia gas, to form the ammonium chloride. Please let's take note of that. This is the hydrogen chloride gas from this reaction reacting with ammonia gas to form the ammonium chloride salt. Now reaction with copper 2 oxide. Ammonia also behave as a reducing agent when it reacts with copper 2 oxide to produce nitrogen gas and metallic copper. Now this is the copper 2 oxide reacting with the ammonia gas. As you can see, the copper 2 oxide is reduced to metallic copper, and the ammonia gas is oxidized to nitrogen gas. Also, let's take note that some water molecule is also produced. Now, ammonia as a precipitating agent. Aqueous ammonia precipitates insoluble metal hydroxide. For example, we have the lead hydroxide and you also have the zinc hydroxide. They are example of insoluble metal hydroxide from solutions of their salt. Now, this lead trinitrate 5 reacting with ammonia gas in aqueous form, that means ammonium hydroxide, to form a deposit of lead hydroxide. As you can see, it is a precipitate, that's why it's in solid form, and the ammonium trinitrate 5 salt. Now you can see that the metallic hydroxide, the lead hydroxide, has been precipitated from its salt, the lead nitrate. Now this is the ionic equation for the reaction. Now the lead Pb2 plus from this lead nitrate and the OH minus from the aqueous ammonia. Then it forms the lead hydroxide, which exists as a precipitate in the solution. Now to test for ammonia in the laboratory. Now you can test for ammonia in the laboratory using the litmus paper, and also can test for ammonia by its reaction with hydrochloric acid. Now when a moist red litmus paper is held in a jar containing the ammonia gas, its color changes from red to blue, and this proves that ammonia is an alkali gas. That means when dissolved in water, it's from the ammonium hydroxide, which is also known as the aqueous ammonia, which changes the red litmus paper to blue. Now, the second way we can test for ammonia is the reaction with hydrochloric acid, as we mentioned before in its chemical properties. Now, when a glass rod is dipped into a solution containing hydrochloric acid, then inserted into a gas jar containing ammonia gas, a white film of ammonium chloride would be formed, just like the reaction here. Hydrogen chloride gas. Here you have the hydrogen chloride gas reacting with ammonia gas to form the ammonium chloride salt. But here we have the hydrochloric acid reacting with the ammonia gas to form the ammonium chloride salt. And to the uses of ammonia. Liquid ammonia is used as a cooling agent in refrigerators. And also ammonia is also used in the production of trinitrate 5 acid. And ammonia is also used in laundries to remove stain. And also ammonia is also used in the production of ammonium sulfate, which is an important compound in fertilizer production. Now here are some assignments for you guys for today's lecture. And we'll end our lecture with this. Thank you for watching this edition of Spice and Secondary School Online Chemistry class. Hope to meet you again in the next edition of the class. Thank you.